Okay, so here P, Q, R, S are the midpoints of the side. So you can just make some indication to help yourself out. Another color, blue color. Show that PQ parallel to AC. PQ parallel to AC. So now, in order to prove that PQ is parallel to AC, we want to be able to write AC in terms of PQ. Or the other way around is fine. Okay, my objective in my mind, I want to do this. A, and then I end up with AC equals to something PQ. Or the other way around. Or PQ equals to something AC. The moment I'm able to write this down, it means that they are parallel already. Okay, so do you think you want to go with option number 1 or option number 2? Want to go with 2, is it? Excellent choice. Why you choose 2? Both are fine, but there is one that is a little bit better than the other. 1 or 2? Look closely at the question. What did they ask you to show? PQ equals to half AC, right? So if you're able to show number 2, that means you would have done part 2 also already. Well, if you actually chose the first option, then it is just one more step, just 1/2 can already. Okay. So now my objective, I want to be able to write this down. PQ in terms of AC. So to go from P to Q, you can choose any point. Maybe let's start with B. Okay. B as the intermediate point. So P to Q, we go P to B and then B to Q. Shall we do that? Okay, so let's write that down. Again, many ways of doing it. PQ equals to PB plus BQ. Okay, next one equals to, I'm trying to link this back to AC. Now let's look closely at PB. PB is this portion. Because P is the midpoint of AB, then PB can be said to be half of AB. Right? So this PB over here is half of AB. This is half of AB. Same direction. Okay? And then we do the same for BQ. BQ is actually half of BC. So plus half of BC. Half AB plus half BC. You can factorize out the half. You can treat it like your algebra. Half AB plus BC. So AB plus BC is going from A to B and then B to C. A to B and B to C. So let's trace out the root A to B and then B to C. Isn't that the same as half of A to C? So we don't need brackets anymore already, right? Now we have done what we set out to do. I have managed to write PQ in terms of AC. Our conclusion is that, therefore, PQ parallel AC. Done. So this is shown. The moment you can write a vector equals to k times of another vector, it means that they are common parallel already. Maybe opposite direction, but definitely parallel. Okay. So next part, show that PQ is half of AC. Have you already shown it? Yes. The magnitude of PQ is half of the magnitude of AC. Also shown. So I was saying that I like to write it this way: PQ magnitude equals to PQ magnitude is actually half of AC. But because they wanted it in this format, you just write PQ equals half AC. Shown. So without the arrows, we're just talking about magnitude only. just like any of our diagrams that you have been working on before this year, before vectors. PQRS is a parallelogram, the length, PQ, no arrow, so talking about length. In this case, magnitude. So next one, part B, show that PQRS is a parallelogram. Okay, so to show that PQRS is a parallelogram, what is our strategy? Any strategy to show that something is a parallelogram? What makes a parallelogram a parallelogram? Two parallel sides? Yes. Okay. Is part A able to give us a clue? What do we do in part A? To show that PQ parallel to what? PQ parallel to AC. PQ parallel to AC. Do you think you will be able to tell me the relationship of AC and SR? If you just repeat the steps, right? You will eventually be able to tell me that eventually you should be able to tell me that SR is gonna be half of AC as well. Yes? Because there are no numbers given, right? It's just half. Everything is just the midpoint. So it doesn't matter what the length is, we expect to come out with this conclusion. Now, the moment we say that SR is half of AC, and we also knew earlier on that PQ is half of AC, wouldn't that therefore imply that PQ is exactly the same as SR? So this part, you just do yourself the dot, dot, dot. Now, if you can prove that two vectors are the same, they are the same magnitude, they are parallel, then you can also do so for the other diagonal. This and this, as well as this. So you just repeat the steps, you will prove that two opposite sides are parallel and have the same magnitude. So proven. Okay? So this one is a bit tedious, but it's just practice for you. So I'm not going to go through it anymore. It's just a repeated steps. Next one, example, try it number 26. So need help for this, anybody? Need? Okay. So here we have OPQR parallelogram. So OPQR parallelogram, just remember, opposite sides parallel, and in fact, same length, same magnitude. Okay, so parallelogram, M is the midpoint again. T is a point, such that OT to TQ is 2 is 1. Did you all draw this on your diagram? OT, you put a 2 and you put a 1 here. Did you all do that? You must do it. It helps in your visualization. OP is for you, okay? OR is 3B. Express PT in terms of U and V. Part A, PT. So in the diagram, from P go to T. I cannot go there directly. I need to find some other way to do it. So what would you like as your intermediate point? You have two choices, either Q or O. Which one would you like? Cannot go directly. So either you go to Q first or you go to O first. Which one? Q? Up to you all. So you want to go to Q first? Yes, you can. Let's break this down to become PQ plus QT. I do not know where I'm going with this yet, but I know that definitely I need to break it down. Okay, so PQ. What is the vector for PQ? Do we know already? Yes, it's a parallelogram. How much is it? 3B. The worm at the bottom. Now, QT. To go from Q to T, I don't know how to do it. But what clue do I have already drawn? 1/3. Right? QT is actually 1/3 of something. Of what? Is it OQ or QO? Remember, you're trying to go from Q to T. So this part is 1/3 of which direction? QO. So put it down. Okay, so now our problem, initially we want to find PT, right? Now our problem is trying to find QO. Is it very difficult? QO? Let's see what we can do. So copy this down, 3B plus 1/3. Now QO, we can go from Q to P and then P to O, correct? Let's continue to break them down. Q to P, then P to O. Yeah? Or you can go the other way lah. Q to R, then R to O. Also the same. So 3V plus 1/3 QP. Q to P is negative 3V. P to O, negative 4U. Okay? Expand it out. 3V minus V minus 4/3U. Simplify 2V minus 4/3 U. And was this the part you needed help with, Queen? Or part B? Okay, part B, what does part B say? You prove that they lie on a straight line. Do they look like they're on a straight line? Look like, we call this collinear. So how do we prove that 3 points are collinear? 3 points collinear, how? Common point? Yeah, okay. So which will you choose to be the common point? P, okay, if you say that you want P to be the common point, then what vectors will you choose to prove they are parallel? Because you need to show that two vectors are parallel plus they are common point, right? If you choose P as the common point, then what two vectors should you prove are parallel? PT and PM. Yes. So PT and PM. Can you prove that they are parallel? So that's the objective lah. Usually we go the other way around. Okay, we want to say that okay, two vectors are parallel, then we talk about a common point. But it's fine the other way also. So let's go with part B. We have a plan. Our plan is to prove that. In your mind, prove PT equals to something, this K times of PM, or the other way around, also can. So let's start. PT, we have PT already, 2V minus 4/3 U. Let us now try to find PM. P goes to M. So which way will you go? You can't go directly. P to Q. Okay, that's a great choice. P go to Q. And then after that, Q go to M law. Okay, so P to Q. We know that this is the same as 3V. 3V. Q goes to M. M is the midpoint. So half of, is it half of 4U? Then half of what? Is it half of 4U? Is it half of 4U? Decide. I will go with the majority. Okay? Who thinks it is not 4U? Raise hand. 1, 2. Not 4U, Only 2 people. So the rest should think it's 4U, right? The rest of you think it's 4U, Okay, let's continue. Let's see what happens. 3V plus 2U. So now my PM is 3V plus 2U. Our objective earlier on, we say we want to write PT equals to K times of PM. Okay, so we are comparing PT and PM. Are you able to write one in terms of the other? So PT equals to K times of PM. This is what we want to have. Our PT is 2V minus 4/3U equals to K times of 3V plus 2U. What will your K value be? You have two options. You can choose to compare the V or you can choose to compare the U. What? 3 over? Is it 3 over 2? So let us just compare the 2V and the 3KV. Okay, watch. 2 equals to 3K. K equals to 2 over 3. So we are trying to say that 2V minus 4/3U equals to 2/3 3V plus 2U. Is this true? Compare the first one, 2V and this. Do you still get 2V on the right hand side? 2/3 times 3, is it 2? 2/3 times 3, is it 2? Yes, it is. But what about the negative 4/3u versus 2/3 times 2. Do you get negative 4/3u? Look closely. Is negative 4/3u the same as 2/3 times 2? No, it's not. It's different. Oh no, it doesn't work. This doesn't work. You didn't manage to prove that PT equals to K times of PM. That means you didn't manage to prove that they are parallel. If they are not parallel, can they be on the same line? If they are not parallel, can they be on the same line? Cannot. Question something wrong? Or you're working something wrong? They say prove that they lie on a straight line. They didn't say, are they on a straight line? That's it, prove. That means they tell you it's on straight line already. That means you cannot end up with a case of being unable to represent one vector in terms of the other. So what went wrong? See the question mark over there? I asked you earlier on. Is your QM equal to 4u? Look closely at the diagram again. Is QM equals to half of 4u? Who is unsure? Raise hand, I will guide you. Okay, who is certain what QM should be? Raise hand. Okay, can you tell me what is QM supposed to be? Yeah, it was supposed to be negative 4u. The direction was wrong. Now what happens if I edit it now? So 3v minus 2u. Okay, so we go through the same process again. I want to say that 2v minus 4/3u is supposed to be k times of 3v minus 2u. I want to be able to say that, and I want to determine the value of k now. So k, 2 equals to 3k, k again is 2/3. So this was changed to a minus 2u. So this is my check. 2/3 times 3, yes, I get 2v. 2/3 times negative 2u, I do get negative 4/3u. So yes, you have proven it. You have shown that. By the way, this one is if, because we were unsure. We are unsure whether we can prove. So if PT is actually equals to k times of PM, we will obtain k equals to 2/3. So k will be equals to 2/3. Therefore, PT, right, wrong. PT is 2/3 of PM. Now I have managed to prove that they are parallel. Is that enough to prove that they lie on a straight line? No, we need one other information, which is they have a common point. And what is the common point? Look at the names. What is the common point? Yeah. So since PT parallel PM and P is a common point, then P, T, M they lie on a straight line, right? They didn't say collinear. So it's the same thing. Just follow the language. Lie on the same line. Can? So over here, we are trying, when you want to prove two lines are parallel, you just pretend that they are parallel first. You find the value of k by comparing only one of the terms. And then you test it out for the other, whether it makes sense or not. If it fits, then you are right. If it doesn't fit, something went wrong. Anybody need more time for this? Okay, example number 27. Find, wait, I just want to show you part A and part B only. Don't need you to do. That's only different new concept. Actually, not also new, not really new concept. Something different, okay? So in this diagram, AB is 6P plus 3Q. Then BC negative 3p minus 5q, AD, p minus 3q. Show that AB parallel DC. We have learned how to do that already. Okay, here. AB equals to 3DC. The moment you have that, AB is confirmed parallel to DC already. The next part is what I'm interested in. Find AB over DC. Watch, I'm going to show you wrong presentation. It is very tempting to do this. So if you don't pay attention, you might be tempted to do this during the test. I'll mark you wrong. This is if you have some basic knowledge of algebra, which all of you have. So it's very tempting to do the following. All right, in part A, we know that AB is equals to 3DC. And then in part B, they want AB over DC, right? AB equals to, what was that? 6p plus 3q. And then DC, 2p plus q. When this happens, some students write it 6p plus 3q divided by 2p plus q. Can or cannot? Can or cannot? Vector divided by vector, can? Cannot. You cannot have vector divided by vector. Even if you say, how about if I draw this? Still cannot. You are still doing vector divided by vector. Okay? So the proper way to do this is only by using the result from part A, where it was already shown AB equals to 3DC. Then you conclude that A for part B, talk about the magnitude. AB is 3DC. No more arrows. Now you can use your algebra. Because when you don't have arrows, you're talking about magnitude. So AB, they wanted AB over DC. Now you can just treat them as your algebra already. 3 lor. Okay, you can even draw the magnitude symbol if you want, but you don't have to. So that's the only new type of question that I want you to be familiar with. The rest are all the same already. So now we're ready to do exercise 6.4. So the questions I want you to do, question 6, 8, 11. 6, 8, and 11. Please do it now.